In this video we are going to talk about how to find the inverse of various functions and, given two functions, how to prove that they are inverses of each other. For example, let's start simple. If we are given a list of ordered pairs, if I want to find the inverse, I will simply reverse the x and the y. So this would be 4, -3, and -7, 6, and 0, -1, and 8, -5. Now, for problem number 2, write an equation for the inverse relation. So what we're going to do is we're going to switch the x and the y and then solve for y. That's basically how you find an inverse relation. Now f of x is like a y. So when I say switch x and y, I mean put x here and put y over here. Now I need to solve for y, which means get y by itself. So I would subtract 6 from both sides. So that's going to leave me with x minus 6 is equal to -2y. And then I need to divide both sides by -2. Now I could put a big giant -2 like this. Alright, so that would be one version of my answer right there. So I could write f inverse of x is equal to x minus 6 over -2. By the way, so don't leave y as part of your answer. We started off with f, so we're going to end up with f, except we'll put this little -1 superscript right here. It's called f inverse, to show that this is not the same function. Obviously, it's a new function, and specifically it is the inverse function. Okay, so that's one version of our answer. Another version would be if I put f inverse equals, and I could take this x and put it over -2. -6 divided by -2 is +3. So these would be two different versions of the same thing. Number 2b, same thing, we need to find the inverse. So this is like y. So first we switch x and y. So that would be x equals 5 over 2y minus 10. We switch x and y. Now we just have to solve for y. So your first move should be to add 10 to both sides. So that's going to give you x plus 10 is equal to 5 over 2y. Now, here's what you cannot do. You cannot put 5 over 2 over here and put 5 over 2 over here and just cross these out like that. You can't leave a fraction inside of another fraction. So we need a different strategy. What I would do is I would just multiply by the denominator. So if I would multiply by 2 here, and multiply by 2 here, and multiply by 2 here, like all three places, these 2's are going to cancel each other out. But then, so that's going to leave me with 2x plus 20 is equal to 5y. Okay, now I'm going to get y by itself. So I'm going to divide everything here by 5. So now these will cancel. So this will give me my final answer. Make sure, okay, so this time it was function g. So instead of f of x, it was g of x. So this will be g inverse. So again, we use that notation with a little -1. So g inverse is equal to 2/5 x, that's this part, course, 20 divided by 5 is 4. Alright, number 2, part C. Again, we're finding the inverse. So this is like a y. So we're going to switch x and y and then solve for y. So if I switch x and y, that's going to look like this. Now if I solve for y, I will subtract 12 from both sides. That's going to give me x minus 12 is equal to negative 3y. And then I'm going to divide everything by negative 3. Now I could make one big fraction and sort of leave it like this. So one version of an answer would be f inverse is equal to x minus 12 over negative 3. Okay, or I could take this negative 3 and split it up under each of these. So that would give me f inverse equals x over negative 3 plus 4. Alright, because negative 12 divided by negative 3 is positive 4. So number 2D, again I'm finding the inverse. This is like a y, so I will switch x and y and then I will solve for y. So if I switch x and y, I've got x equals 3 over 2y minus 12. So now I need to solve for y. So I'm going to add 12 to both sides. So that's going to give me x plus 12 is equal to 3 over 2y. So I think the easiest thing to do is multiply by the denominator when you have a fraction and you're trying to get that variable by itself. So I would multiply by 2. You have to do this everywhere. Okay, all three terms in this equation. Now over here, these 2's are going to cancel each other out. So on the next step, I will have 2x plus 24 is equal to 3y. Alright, then you need to divide everything by 3. So that's going to leave, this is function g, not f. But instead of calling it just function g, I call it g inverse with a little negative 1. And I've got 2/3 x, alright, that's this part. Now 24 over 3, 24 divided by 3 is 8. Alright, for number 3, I'm supposed to use function composition to verify that f and g are inverse functions. Alright? So it's like we're doing a little proof to verify. And here's how you do it. If two functions are inverses of each other, then if you substitute one function into the other function for x, then everything should cancel out and I should get x. Okay, so here's what I mean. Let's start with function f, which I will color blue. Function f is this 4x plus 32. But I'm going to start off by writing, instead of 4x plus 32, I'm going to write 4 parentheses plus 32. Okay, let's see how much space I'm going to leave. Okay, so 4x plus 32 has become 4 parentheses plus 32 because I'm ready to substitute something in here for x. Now the thing I'm going to substitute for x is going to be function g. Alright, so I'm going to take this entire function and put it right here. That's why I'm going to have x over 4 minus 8. So I've substituted one function into the other. Now, if everything cancels out and we get x, then we will be halfway to proving that these two functions are inverses of each other. So let's see what happens. So you take this 4 and you do a little distributive property. Okay, when I multiply x over 4 by 4, these 4's wind up canceling out, and I just have x. So 4 times negative 8 is negative 32. So I will have x minus 32. Now the blue plus 32 just comes down. And you can see where I'm headed with this. The negative 32 and the positive 32 cancel each other out. And I'm just left with x. Now we knew that we were going to get x, but it's not that the answer is x. This whole procedure is the answer. So you have to show these steps exactly like this. Okay, now we have to do it the other way. That's why I left all the space over here. Now we have to substitute function f into function g. Okay, so here's function g as x over 4. But instead of x over 4, I'm going to have parentheses over 4 minus 8. Now I don't actually need the parentheses in this case because the fraction bar itself is a grouping symbol. So this numerator is automatically going to contain whatever x used to be. So of course I'm taking the function f and putting it here where x is. So I will have 4x plus 32 over here. Alright, now when you take a binomial and divide it by a number, I can take that number with which I am dividing and write it twice, once under each term. So look, here's my 4x plus 32 that I had a moment ago. But I'm going to take this 4 that I'm dividing with and split it up under each one, 4 and 4. Meanwhile, I still have this minus 8 that I just brought down. Now these 4's are going to cancel out. So now I have x plus 32 divided by 4 is 8. And then I still have this minus 8. Now obviously positive 8 and negative 8 cancel each other out. And I just have x. You must show each one of these steps separately for full credit. Alright, so that was number 3a. Now let's look at number 3b. So same thing. If I want to prove that these functions are inverses using composition, I need to substitute one function into the other. So 8x plus 16 becomes 8 parentheses plus 16. And inside the parentheses, I'm going to put the other function. So I've got x over 8 minus 2. So of course I'm going to do a little distributive property with this 8. When I do 8 times x over 8, these 8's just cancel out. So that just leaves x. But then I've got 8 times negative 2 is negative 16. Alright, then I'll have the positive 16. So these will cancel each other out. And you just get x. So far so good. But now I need to take function f and plug it into function g. So this time I'm going to start off writing function g. So x over 8 minus 2 becomes parentheses over 8 minus 2. Here again, we don't really need the parentheses. See, notice how there's nothing in front to distribute. So I can just go ahead and do this. So x is now being replaced by 8x plus 16. So I've got 8x plus 16. Okay, I'm just going to divide each of these terms by 8. So it's like I'm doing this. There's my 8x plus 16. but I'm dividing each of these by 8 like this. And I'm just bringing down the minus 2. Now right here, these 8's just cancel themselves out. But then I've got I've got x plus 2. And then we have minus 2. And here again, the positive 2 and negative 2 cancel each other out. And we have x. So that was number 3b. Okay, again, if I want to show and prove that these two functions are inverses of each other, and it's still problem number 3, I will substitute each function into the other and see if I get x both times. So let's see. I'll do function f in blue, and I'll do function g in red, but 4x plus 20 becomes 4 parentheses plus 20. Now, so here comes function g. So I will put this in here, so that will give me x over 4 minus 5. If I do the distributive property right here, when I multiply 4 times x over 4, these 4's cancel out, and I just get x. 4 times negative 5 is negative 20. Of course, I will bring down the blue positive 20. And now you see that the negative 20 and the positive 20 cancel each other out. So that just leaves x. So far, so good. Now I need to do the same thing over here, but this time I'm substituting function f into function g. So x over 4 minus 5 becomes parentheses over 4 minus 5. Now, because these parentheses are in the numerator, I don't really need parentheses. The division bar itself acts as a grouping symbol and makes it 100% clear. So I'll have 4x plus 20. Alright, just copy that right there in for x. But now I need to separate this and divide each of these by 4 so I can see what's going to happen next. So I'm going to still have my 4x plus 20 for one more moment, but I will take the 4 and write that under each term. And I'm still going to bring down this minus 5, just bringing that down. Alright, of course these 4's cancel each other out, so I have x plus, and then 20 divided by 4 is 5. And then I've got the minus 5. So these are going to cancel each other out, 5 minus 5. And that will just leave x. So because we got x both ways, that proves that these functions are inverses. And yes, you have to do it both ways to complete the proof. You can't just do one. Okay, let's look again. And again, this is still problem number 3. Alright, so let me just split this down the middle because we have to do it both ways. So, to show these are inverses, I'm going to substitute each function into the other and see if I get x both times. 7x minus 21 becomes 7 parentheses minus 21. Alright, that's function f right there. But now I'm going to substitute in function g. So x over 7 plus 3. So here I've got x over 7 plus 3. When I do the distributive property, then 7 times x over 7, these 7's cancel each other out. So that just leaves x. But then I do 7 times 3, and I get 21. So I bring down the minus 21, and these cancel each other out. So I just have x. So far, so good. Now, how about function g? X over 7 plus 3 becomes parentheses over 7 plus 3. Okay, I don't really need these parentheses, right? So, because normally inside of the parentheses, this is where I substitute my 7x minus 21. But see how there's nothing in front of the parentheses, or there's no exponent out here, there's nothing to distribute. So I don't really need the parentheses at that point. So I'm just going to erase them. Okay, now I'm going to take this 7 and use it to divide each term. So, but I'm going to show my steps very carefully. So here's the 7x minus 21. I just recopied it. And here I'm taking this 7 and I'm writing it under each term separately like this. That's equivalent. And here I'm just bringing down the plus 3 that's been there all along. But I did it this way so you can see that these 7s are going to cancel each other out. And then that's going to leave me with x minus 3. And then plus 3. Minus 3 plus 3, you say. Well, we know those will cancel each other out. And then I just get x. Because I got x both ways when I substituted each function into the other, that proves that these functions are inverses of each other.